Okay, guys, I'm going to walk you guys through some of these notes and see if we can find the volume of cylinders today. All right, pretty similar to finding the area of some of our other shapes, but now we're going to be dealing with circles. So, a little quick warm up to start. And that says label each figure as right or oblique and then answer the question. Well, right or oblique? Very simply put, a right, whether it be a 3D, 3-dimensional shape or a 2-dimensional shape, has to have a right angle. Figure K, it would be considered right because it has a right angle. We assume there's a right angle right here. Whereas figure R does not have a right angle, so we're going to call that oblique. Okay? Now we can kind of look at the base. You can look at this face as well. Either one can give you that option. So we can think about the bases or the face kind of looking directly at us to determine if it's right or oblique. Which figure has more volume? Now this is a question that you're going to see a lot. Discussing which has more volume, a right shape or an oblique shape. Well, let's think about this real quick. Could it be figure K because it's straight? Could it be figure R because it's slanted? Will this be impossible to determine? Or do they have the same? Well, figuring this out, the area of the base of K would be length times width, or 48. To figure out the volume, we would do length times width times the height, so 48 times 4. Well, in figure R, we'd really be doing the same thing. Area of the base is 48 times the height of 4. So in either case, the volume would be 8 times 6 times 4. So therefore, they would have the same area. It does not matter that one is slanted or not. It matters about the numbers employed in the shape. Right? The volume is length times width times height. Or, because we're going to talk about this again today, the volume is the area of the base times the height or times the depth, if you want to think of it that way as well. All right, let's jump into cylinders. So, cylinder volume. All right, we had that little stacking technique talking about how this cross section is the same throughout the entire shape. So if we can figure out the area of the base and multiply by the height, then it'll be the same exact shape. Only thing that's a little different today is the cross sections are circles, obviously because we're dealing with cylinders. And the formula for the area of the base of a cylinder, well, since we're dealing with circles, the formula is pi r squared, or pi times the radius squared. Therefore, you can see the formula for the cylinder, volume of the cylinder is base times height, or we see the area of the circle right here again. That's the area of a circle times the height. Okay, let's move on to some examples now. Get that out of the way. All right, Cavalier's principle works with cylinders as well. Again, it's just saying that if we find the each cross section has the same area, all right, kind of like the stacking principle, but each of them has the same area. So therefore, right and oblique cylinders that have the same height and radius also have the same volume. So if we look at this figure, it doesn't matter that this cylinder is slanted, because if I can find, let's say, the area of this base and the area of this base, and they'd be the same. Well, if their heights are the same, then the volume is likewise the same. All right, let's jump into some examples. Determine the volume of the figure, or all these figures. Well, again, the volume of a cylinder is the area of the top times the height, or the area of the circle times the height. In this case, it would be 4 squared times pi times the height. Now, you can write this in any order. I'm not going to nitpick you guys like, oh, the pi has to be here, the pi has to be there, etc. Doesn't matter. But we should have this number combination. Now, we don't need to use 3.14 or the pi key on your calculator. We'll just leave our answers in exact form and write our answer as 112 pi. 4 squared is 16. 16 times 7 is 112. All right? So we can leave it just like that. All right? And we should throw on some units on there as well. So centimeters cubed for volume. Now, B, as well as C and D, requires to do a little extra work here. It won't always be as straightforward as this first example. In this case, remember, I want to figure out the volume is the radius squared times pi times the height. Well, I don't have the radius right now. I have the circumference. So first I have to work my way backward to figure out what that radius is. Well, if you recall how to find circumference is simply 2 pi r. So if I know the circumference is 6 pi, therefore the radius must have been 3. Dividing 6 pi by 2 pi, we get 3. So now I can input my radius into this formula as 3 squared times pi times the height of 3, or 27 pi cubic centimeters for my volume. Now down here, notice this is 1/4 of a circle and this is 3/4 of a circle. We're going to see shapes like this, kind of these weird, like almost cutouts, happens very often in this section. So when we want to deal with this, realize we're dealing with 1/4 of a circle. So the area of this face, this front face here, if I want to find the area of that, remember, we can think about it, it's the same cross sections throughout the whole shape, right? If we were to slice it. The area of that front face would be area of a circle, the radius, this is the radius 6, so this, like, imagine a circle going all across, times, or squared, times pi. But that would be the area of a circle if this was a full circle. So this is 1/4 of a circle. We're going to multiply this by 1/4. So the area of this front face is simply 9 pi. 6 squared is 36. 36 times 1/4 is 9. That's the area of the front face. Then the area or the volume of the shape would be this area of the cross section or the base times the height. And we also think of this as like times the depth, or how many of those cross sections there would be. So times 10, and we get 90 pi centimeters cubed. Right? Now this one is 3/4 of a circle. Now one way to know this, you might be like, how do I know it's exactly 3/4, Mr. Peretti? Well, something I start to tell you, if you look at these right angles, if I have right angles in these shapes, in a circle 360 degrees, if I have right angles, that means I'm splitting it into quarters. 90 is 1/4 of a of 360. So this would be 1/4 because there's that right angle there. This would be 3/4 because I still see that right angle here as well. Okay? So now we want to calculate this, the area of that front face. The radius squared times pi. But it's only 3/4 of a circle, so we're going to multiply by 3/4 there. Right? We get that as be 3 pi. That's the area of this front face, the base. Then we're going to multiply by the height, or again, we could use this word as depth if you want to say it that way as well. But it's how many times that cross section would be repeating itself. Times 5, and we get 15 pi cubic centimeters. All right, great job. All right, almost done. Take one more glance at this page, take a picture, jot it down, pause it, or come back. All right, last section real quick. Quick little multiple choice here for you guys. All right, I'll let you guys read through it. On your own, but come back, see if it makes sense. All right, see if it makes sense. We're going to check off box 2 and box 4. Read through it. If you have any questions about interpreting that, come back and maybe message me. But I'm going to give you guys time to read through that and kind of rationalize that in your brain a little bit. I want to get down to a couple more examples for you guys. This first one's another example I'll let you guys do on your own. This one, I'm not going to solve the whole piece, but I would need to know the height for this cylinder. The height is this amount right there. I don't know it right now. I just put an H. It's tough to see, but this is supposed to be a right angle right here. Oh, sorry, apologies, not there. This is supposed to be a right angle right there. So this is a right triangle. Well, if I can imagine a right triangle in this shape, a right triangle, I can use Pythagorean theorem to come up with this H value. You might recognize this as a Pythagorean triple. If you use some math to work this out, you would come up with H is 12. You can then use that to find the volume of that cylinder. I'll let you guys do that one on your own. Just want to show you that trick involving finding the height when they give you the diagonal. This extension problem, this was a little wacky because it's a weird looking shape, right? But we're going to almost split this into two parts, like a composite figure, okay? I'm going to find the area of this top portion first, okay? Find the area of this top portion first. So if I want to find the area of this top portion, okay, so I'm talking about the semicircle and back, okay, I'm splitting up this way. There's a couple different ways that we can split this up, right? If I want to find the area of this top portion and then extending back, the area, I keep saying area, but you guys know what I mean. I'm talking about volume because we're talking about 3 dimensionals. If I want to find the area of this top half, well, the top would be 1/2 because I'm dealing with a semicircle times the radius. Notice the diameter would be 6, so the radius is 3 times pi times the height. This would be if I kind of took this semicircle, this is top half right here, and backwards. Well, the area there would be, the volume would be 99 pi over 2. Well, I also need to find the area of this bottom portion as well. I also need to find the area of this bottom portion as well. Notice, this is just a rectangular prism with a semicircle cut out from it. So this is the top half. We're going to add it to this bottom half. Well, if I treat this like a rectangular prism, so length times width times height, or base times height times, length times width times height would be 6 times 2 times 11, but then we have to minus this area of the semicircle that has been removed from the shape. So in that case, it would be 1/2 times 2 squared times pi times 11. That's a weird looking expression. But the way that simplifies would be, this would be 6 times 2 is 12, or times 11 is 121, minus 1/2 times 4 is just 2. So we get 22 pi. If you bring this down as well. My last step would be to combine my like terms of 99 pi over 2 and 22 pi, because these both have pi in them. Now we might want to think about getting a common denominator over here and keeping it over 2. We can rewrite 22 pi as 44 pi over 2. So I can rewrite this as 44 pi over 2. So we have a common denominator. Now I can see, all right, well, 99 minus 44 is 45 pi. So my final answer will right over here is 121 plus 45 pi over 2 cubic centimeters. All right, that's it for me today. Email me, comment on this, or comment on Google Classroom if you need any help. Have a wonderful weekend, guys, and thank you for keeping up all the hard work.